but I think that this is something that's going to help you kind of visualize what we're doing. So we've talked about the idea that sound is a wave. We can draw it like this. I mentioned that a while ago. This isn't really what sound waves look like. Sound waves are compression waves, and these are transverse waves. And those are really two different things, but it's much easier to draw waves like this. Sound waves don't go up and down. They go back and forth. They go squish, 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 stretch, stretch, stretch. I can't say those words that quickly. And the speed with which those vibrations occur. So a sound wave in the air might look like this, or it might look like this. The speed with which those vibrations occur determine the pitch, the tone. So low frequencies, where the squish and the stretch are like this, are real low notes. High frequencies, where the squish and the stretch are like this, are real high notes. When we use our xylophone bars, and this is, as an aside, I asked my physics class this today because I keep looking online and I keep seeing like xylophone, marimba, vibraphone. I don't know what the heck the difference between any of these things are. So let me be clear. I don't really know what we're building. I just know how we're building it. I need to figure out the difference between those. But when we like plunk on this, what happens is this piece of wood vibrates, and that makes the air vibrate. The frequency of this wood vibrating affects the frequency with which the air is vibrating. That's why changing the wood changes the sound, okay? Maddie, will you move to the back table? And so you can see it visually in a couple of different ways. One is that if you actually could see one of these tone bars vibrating, you'd see something like this. And in fact, we're gonna see one in just a minute. But graphically, we can draw it like this, where we have a wave, where there's parts of the wave where it doesn't seem to move at all, like here. And there's parts of the wave where it seems to move a lot. It's right here. And the geometry of all of this will determine how quickly this wiggling happens. Now you can't see that here at all. But if we were to film it in high resolution at slow motion, we would be able to see it. And so I just want to show you what that looks like. This is very quick, and there you go. That's what it looks like when this is a vibraphone, tone bar is vibrating. You can see it, right? You can see it's not really vibrating much there. There's this flex like this. And if you looked at a real tone bar and could zoom in and really look at it closely, what you would see is not only is it vibrating like this, like a jump rope, but it's also got two little mini jump ropes in it, one here and one here. And not only is it doing that, but it's also got 3 other jump ropes in it. 1, 2, 3. And actually that just keeps going. Those are in sound what we call harmonics. And that's what accounts for the fact that a note played on different instruments sound different. It's not the note itself that sounds different, it's all the harmonics around the note. And so we're not gonna worry too much about harmonics. But it turns out that if we were to worry about harmonics, we would need to think about the thickness of our bar in a whole bunch of areas. One is right in the middle. One is here and here, the thickness here and here. One is here and here, the thickness here and here. And the truth is that we won't have the time, and I don't think any of us is going to have the expertise. Some of you might be able to do it. I don't think I could, to really precisely figure out the geometry. But luckily, we won't need to. We really are going to have 2 tasks. Okay, one is to get our bar to sing in the right note, and the other is to kind of tune it and shape that sound. So that means that we're going to alter the harmonics. We're not going to do the equations for that, but we're going to try to alter the harmonics in such a way that it resonates and rings and really like produces a relatively long-lasting tone. Okay, so here's what I did. This guy, same guy who put together this this complicated web page, also put together this complicated web page, where he talked about for a specific kind of wood where all these different nodes would be, all the different like jump ropes, and how large the piece of wood should be, how thick it should be at the arch, and how it may be thickness at some of the other nodes. And my goodness, this is a really confusing table. So what I did is I put it all together in this. Okay, so this is and then he was using one kind of wood. We're using all sorts of different kinds of wood. So I came up with maybe a reasonable starting point, but I don't know if this is going to be right. We're going to have to play around with it and see. But if we wanted to make a C4, which is those of you who know music, it's a C note, fourth octave. Okay, so if a regular C, like a middle C is, that's a C2. And we go up an octave from that, that's a C3. And if we go up an octave from that, that's a C4. I don't know if any of those is right, but it's octaves, same note, octaves apart. And so we want that high-pitched C note. That's pretty close. It's not right on. This actually, I think we did this, and this is closer to a B, as it turns out. But what I did is I took his calculations and measurements and just penciled out a starting point for everybody. And that starting point is what I want you to write down. And it is that you need a piece of wood that's about 15 inches long. So 15 inches is longer than a ruler. It's longer than what most of you make. And we'll see. That might end up being too long. We're going to have to, there's no other way to do this besides to experiment. And then that will be trimmed with this arch, and many of you came back with like arches in various shapes, and some of them sounded great, but if we want to be able to kind of design something that's going to make the notes we want, as opposed to just like, well, I cut a circle and it sounds good, then we're going to need to be able to do this with measurement. And so what it looked like was about a 1/4 inch from each end is where that arch would start. And let me double check that, because yeah, 15. Yeah, not a 1/4 inch. Sorry, a 1/4 of the way is what we want, about a 1/4 of the way. So this is 15 inches. So this is going to be about 4 inches here. I'm glad that I looked. I was awfully tired when I put this together. So it's going to be about 4 inches here, which means this section in here is going to be about 7 inches to start. Okay. And then this section here should be about 1 inch. That's conservative, meaning that I think that this will produce a note that is higher than what we want, meaning that we'll start cutting more material out to make it lower and lower and lower. And I'm not sure the best way to kind of tune it, but what I think we're gonna have to do is like get it to sort of like sound a little bit high, like we want the pitch to be a little bit high so that we can carve out material just from this section to really get it to be the note we want. And like I said, if you look at all those different jump ropes that are going up and down, the waveforms in the wood, it's crazy. The calculations are insane. That's not how they did it in the old days. In the old days, they figured it out for each piece of wood by ear, and then they knew what to do. So they just replicated the same thing over and over and fine-tuned it for specific types of wood and stuff. But we have the advantage of being able to do the calculations, the disadvantage that we don't have a year to put this together. So we're gonna try to use this starting point and see where we get. So today and tomorrow, what I'd like to see is how close you all can get to a really good, clear, resonant C4 note. Here is what that will sound like, by the way. Oh, forget it. I don't have it on here. Sorry. Let me try this. Okay, here is a C4. That's what it should sound like, roughly. That's what we're looking for. That's too low, isn't it? Yeah. So that's going to be our goal. And this one, now that I know this is low, this is going to be a great place for me to start, because now I know, well, I'll just take a little off of, no, it's too late. It's the other way around. And you need to start with it too high, so this isn't going to work. Real quick, does anybody have any questions from me before we get started? Okay. Ms. Reinwald, any thoughts for the good of the order?